On this edition of TLC Elementary School, dive into a world of weather and climate. First, see how meteorologists use technology to predict the weather. Then, follow the path of a tornado and enter the eye of a hurricane to learn how storms form. And watch for classroom activities right after each segment. Segment 1, Meteorology.
The weather. It's there every day. Sun, wind, and rain are basic to life. How can we know when the weather is going to change? If tomorrow will bring storms? We can measure the weather accurately, from satellites to radar. Modern inventions describe the weather today. And this helps us predict what it may be like tomorrow. There's a science to predicting weather, and it's called meteorology. "7 miles high, a gassy bubble surrounds the planet. And that bubble, called the troposphere, is filled with air and water vapor, millions of gallons of it. Higher up are other layers of the atmosphere, the stratosphere, the mesosphere, and the thermosphere. But it's in the troposphere that almost all our weather takes place. The sun drives our weather by heating the earth. Warm air rises, and when the ocean surface is 80 degrees Fahrenheit or more, the rising air carries a lot of water vapor with it. This water vapor cools as it rises and forms clouds when it condenses. But the air can only hold a certain amount of water at a given temperature. When there is too much, the moisture falls to the ground. Clouds are blown around the earth, pushed by wind created as warm air moves up and cool air flows in to fill the space. This movement of warm and cold air causes our weather to change. Meteorologists like Helen Young track these changes, trying to predict what's going to happen next. It's all about air, heat, and moisture, the basic ingredients of weather.
There's 3 things that you need to get weather. And the 3 things are air, you need heat, and you need moisture. Because our atmosphere is really just a giant heat engine, transferring all those elements in the air from one place to another.
Everywhere, the same weather ingredients are mixing, and the job of the meteorologist is to figure out what's going to happen. For meteorologists, predicting weather begins with recording it. Over thousands of years, people have developed tools for recording weather. From thermometers to measure temperature, to hygrometers for measuring moisture in the air. As technology developed, so did our ability to measure weather. Instruments on weather buoys give daily readings from the oceans around the world. And instruments on weather balloons give weather readings from high altitudes. Weather satellites have been in service since the 1970s. They can track the weather around the world and record huge amounts of information. Today, there is little chance that weather changes strike completely by surprise. By using all these tools, meteorologists can predict storms up to 3 or 4 days before they happen. Computers programmed with weather information show meteorologists how storms are developing. This computer simulation at Goddard Space Center in Maryland lets scientists change wind speeds and ocean temperatures to learn what factors will make a storm grow or die. Doppler radar is another great tool for predicting weather. It sends out sound waves and listens for the echoes bouncing off clouds and raindrops. Different colors show the rain's direction, and different shades show wind strength, so scientists can track emerging storms. To get even more precise information, sometimes meteorologists fly airplanes full of equipment right into some of the most violent storms. Scientists drop weather-sensitive capsules that analyze the air all the way down to the ground and send measurements back, recording the temperature, wind speed, and moisture. Now there's something even newer. It looks like a model airplane. But it's actually a robot called an aerosonde. It's a simple enough machine powered by a gasoline engine, but this engine can keep a plane flying for up to 4 days. And it can go anywhere. Piloted by a satellite-linked computer, it carries miniature weather sensors and flies wherever meteorologists want it to fly. No matter how remote or turbulent, sending back the tiniest meteorological details. 2,000 or 3,000 aerosondes gathering detailed weather information could finally allow meteorologists to predict weather further in the future. Even so, with all the new technology, there still won't be any way to change our weather. The Earth is the domain of the sun's heat, the air, and the water. Meteorologists have their work cut out for them, trying to measure the weather and predict what will happen next.
Try this activity to complement meteorology. Collect a series of weather maps from a local newspaper for 5 consecutive days. Describe the weather during that 5-day sequence. What patterns can you find? Try to predict the weather for the next 5 days. Segment 2, Storms.
If it's a day for extreme weather, you'd better be careful. Every year, storms affect the lives of millions of people. Violent rainstorms flood entire villages. Towns are swept away. Thunderstorms destroy houses, and blizzards shut down cities. Some are hurricanes, raging storms hundreds of miles wide. Or tornadoes, not so wide, but extremely powerful. What makes storms like these take place? Most storms start with the development of clouds. Water evaporates from lakes, oceans, and rivers, condenses, and forms clouds. But the air can only hold a certain amount of water vapor at a given temperature. When the temperature changes and there's too much water in a cloud, it falls to the ground as precipitation. Precipitation means moisture, and when it falls as rain, the result is a rainstorm. Some rainstorms drop small amounts of water. Others can cause huge floods. In colder weather, moisture freezes as it falls to the ground, and the result is a snowstorm. It all depends on the temperature of the air in the atmosphere.
The air above the Earth doesn't necessarily have the same temperature profile. You can have bands of areas in the atmosphere going up above the ground that are different. So you might have a very cold layer at the surface. You might then find you've got a warmer layer above that. Any precipitation falling out of that will melt in that warmer layer, and then as it comes down into the colder layer again, actually begin to freeze again. And it depends exactly when that happens as to what you find falling at the surface.
Too much snow can be devastating, especially when people aren't expecting it. But clouds can cause another kind of storm, the thunderstorm. What turns a rain cloud into a thunderstorm cloud is size.
To get a thunderstorm cloud, you've got to have that development of that cloud increasing all the time to make a bigger and bigger cloud.
As a cloud grows, drops of water and bits of ice knock and rub against each other, generating a lot of static electricity. Just as in a battery, the electricity organizes itself into opposite poles. One end of the cloud is positive and the other is negative. When the charges move toward each other, a giant spark is the result. This is lightning. It's 5 times hotter than the sun. It makes the very air explode, which we hear as thunder. At first, the bolts of lightning may go from cloud to cloud. But as the amount of static charge increases, the lightning can strike the ground. It goes for the nearest object, which is usually the highest. Every year in the United States, lightning strikes more than 40 million times. Thunderstorms can be even more dangerous than this. If conditions are right, they can become tornadoes. Tornadoes spiral slowly across the landscape, packing wind speeds of up to 300 miles an hour. But how does this kind of devastating storm develop? In the United States, moist, warm breezes from the Gulf of Mexico sweep up. And very high in the atmosphere, strong cold winds blow down from Canada. Sometimes thunderstorms formed from warm, moist air will get so large that they burst into the path of the icy northern wind. This puts the twist in the twister. At the bottom, the clouds are blowing one way, and at the top, the other. From the ground, you see what's known as a supercell, with a fast spinning center. The spinning lowers the air pressure, sending the supercell's twisting center down from the thundercloud until it touches the ground. And that's when the trouble starts. That's a tornado. Tornadoes look like they're destroying things by sucking them up. But what they really do is just batter with sheer wind power. While tornadoes are damaging storms, they are small compared to the biggest storm of all. Hurricane, typhoon, cyclone. These are names in different regions of the Earth, all referring to the same whirling mass of waterlogged air. This huge storm starts as a thunderstorm that forms over warm ocean water and drops rain. But more wet air moves up from the surface of the ocean to replace it. The Earth's rotation causes vertical winds to spiral around the eye, a calm center. Heat, rain, more heat, wind, more rain, it continues to fuel itself from the warm waters. hurricanes do run out of fuel as they reach land. Without those warm tropical waters beneath them, they slow down and die out. Meanwhile, they hammer coastal communities. Rain washes land from mountaintops. The ocean waves rise to 20, 30, or even 40 feet and flood the coastal areas. It's a terrifying storm. Storms are a natural weather phenomena, and their powers should be respected. We can't stop them from happening, but we can be prepared for them and protect ourselves from them, and in some cases, get out of their way.
Try this activity to complement storms. Scientists estimate that lightning strikes the United States more than 40 million times each year. Use several resources to identify safety precautions to take during a thunderstorm. Design a poster to illustrate one of these life-saving measures.